Hello guys and welcome. In this lecture we will see how to create a pencil sketch picture from a given image using OpenCV. We will make use of the methods that we have seen in the last lectures, like the blurring techniques and other methods. So we will build an application that outputs an image or a pencil sketch picture using a given image, and we can change the kernel size to see its effects on the output image. So let's start. So first let's create a Python file. I will call it sketch or pencil sketchup. Sketchup.py. As usual, I will import CV2 and numpy, and I will read an image from data. cv2.imread data. I will read the image called leaf A, so leave an A, and then I will come here and see show original image, call this image, and then cv2.wait key 0, and then run this Python file pencil. So this is the original image, and we want to create a pencil sketch picture from this image. So now first let's create a grayscale image from this image. So cv2.cvt color to convert from BGR to grayscale image, and cv2.color from BGR to gray. And then we need to take the inverse of this gray, so gray inverse 255 minus this gray, and I will take, for example, if I create the blurred image cv2. I will use the Gaussian blur. We can test the other type of blurring also. So I will blur this gray inverse image, and I will use a kernel size of 7 and 7. You can use the higher one, and also the sigma as 0. So the result image will be, I will call it result cv2.divide this gray image. This gray image we have get here, this gray divided on this, or 255 minus this blur image, and we should give the scale as 256. And we can now convert this result to BGR cv2.cvt color this result image, and give it cv2.color from gray to BGR. And now we can show this image here, cv2.imshow. I will call it result, and see your result. Now we can run the code and see the result here. So this is the result image, and as you can see it here. If you want to try another blurring, you can say here, for example, the average blurring by saying blur and remove this 0, and see it's here. So this is the result of the average blurring. You can also adjust this kernel size. So if I give it, for example, 15 and 15, I can give any odd number here. So you can see the result here. If I change this back to Gaussian blur and give here sigma as 0, let me close this and run it. So this is the result of the Gaussian blurring. We can also create a trackbar to change this kernel size. So if we do that, we can come here, and from here we can saying cv2. named window. I will call it trackbar, and cv2.create trackbar, and give it the name of kernel size, the name of the window, so trackbar. I will give it, for example, 7 as the default number and the max value as 100, and a function that I will create here, I will call it nothing. So this function def nothing take x, and it just pass. So now we should come here and say while true, then do that. We'll make this on this while true, and I will get the value of the kernel size as cv2.get track position. The track name is key size, and the window is trackbar. But this key size can be an even number, and we want it to be always an odd number, so we can come here and say if this key size is an even number, so I mean that its division on 0 is equal to 0 and on 2 is equal to 0, and we can come here and say key size plus 1, increment it by 1 to be always an odd number, and we should change this to this key size and these two to key size. So now everything else is the same. We can, for example, put here saying cv2.put text to print the value of the kernel size on the image. So put it on the result image, and should come here and say key size, give it here as string of this key size. I will give it origin as 0 and or as 10 and, for example, 40, and the font will use cv2.font Hershey simplex, and the font size as 1, the color as, for example, red color 255, and the thickness as 2. So let's see this image now and see the result. We also should, as we are using while true here, we should change this as if this one is equals to order q, then break the loop equals, and then cv2 dot destroy all windows from here. Now we can run the code and see the result. So as you can see, this is the result with kernel size of 7 as default, and we have here a trackbar that we can make it bigger, and we can change it from here. And as we change it, you can see here the value of the kernel size here is 22, but it is changed to an odd number. We can make it bigger and see the effect of a bigger kernel size, or we can make it small kernel size like this one here, 15. If I make it 21, so you can change it, depends on depends on what you want to be the image to be looking. You can try another image here, for example, in the same folder data. If I use this B image, so you can see it also here. This is image, this is the kernel size, it's bigger, and change the value here. So as you can see, we get the pencil sketch picture here from this image. We can also use an image, for example, the Obama image from here. So this is the result image, this is the original image, and the trackbar here. This is a bigger image, it's a very big image, it may take time to change it. We can resize it if we want. We can also use the Messi image. So this is the image of Messi, original, and the trackbar here. So as you can see,